Hello everyone, welcome to another video. I'm going to talk about program counter today and what it really does and how it functions. Now, to understand the program counter, let's try and run this program for once to understand what's really happening. I want to go into the debug mode and talk about the bunch of registers that we already have here, and one of them is program counter PC, the R15 register. Now, before we dive into the code, notice there's a value already stored in the program counter, and this is in hexadecimal 378. And if you look at the disassembly window, the address of the very first instruction, line number 5, move 3 in R3 register, the address of the very first instruction is in fact 378 in hexadecimal. So what does that tell you? That tells us right here that program counter in effect stores the address of the next instruction that needs to be executed, right? So it is fetching the address of the next instruction that needs to be executed. And we can see this happening as we step one instruction at a time. Notice the instruction has now changed to 37C, which is in fact the address of the next instruction, which is moving 4 in register R4. And if we step one more instruction, it's 380, right? So we can see this now, 380 is in fact the address of the next instruction, which is moving 37C in R5, right? So this is what our next instruction is, moving 37C in hexadecimal into register R5. And then the program counter says 384, which is in fact the address to the next instruction, which moves 6 in R6. And then we come out here to our last instruction, line number 9, which moves the value in R5 into program counter, which can be used, and PC is used to reference a program counter, right? And this is interesting because this is actually one of the ways we can use program counter. It's not the best way to do it, but it is one way to make use of addresses within a program counter. And what is it really doing? Now think about it. R5 has a very specific hexadecimal address stored here, which is 37C, right? And we can see in our register set also that in R5 we have 37C. But what was in 37C really? What are we moving in program counter? We're moving 37C in program counter, and in fact 37C, if we scroll slightly up, we can see that 37C was in fact an address for a very specific instruction, which was moving 4 into R4, right? So if we execute this instruction on line 9, what we should really expect is that this hexadecimal value 37C is moved into the program counter. And when a value or an address is present in program counter, that is in effect the address of the next instruction that needs to be executed. And what is the instruction on that address? It is moving 4 in register 4. So let's go ahead and see what really happens when we do this. Now, as expected, we moved the value in R5, the 37C in program counter, and that is the instruction to the next, that is the address to the next instruction. And there we are. We are at line 6. We are at this instruction right away, right? So in effect, what we've really done here is we have come back to the address of this instruction, and this instruction was in fact at the address of 37C. Now what happens after 37C is you move to the next instruction, right? And then when you go over these instructions, you come back to this specific line number 9, where again you move 37C in program counter, and the program counter is gonna take us back to 37C, which is this, right? So basically if we keep on doing this, we can notice that this is one way of implementing a loop or moving towards a specific address location, and often this can result in a never-ending loop. but we could smartly use it to our advantage to move from one address location to another. So in short, this video shows you that the program counter stores address location for the next instruction, and we can use the program counter to our advantage to move to specific address locations. Also interesting to note here is that the increment of the program counter is by 4 bytes. This is hexadecimal, so from 378, when we see this change to 37C, notice in hex, C in fact represents 12, right? So 8, 12, and then 16 becomes 0. The next bit increments and becomes 380 and then 384. So we're seeing an increment of 4 bytes, and that is the size of the instruction that the program counter reserves for one instruction, right? So we move 4 bytes as increments for program counter for these specific instruction, the move instruction, and we notice that the program counter stores address to the next instruction, and we can use that to our advantage to implement different branching and different sort of loops. Thank you.